use algebra to solve the equation. So first of all, if I look at this equation, I notice that I have some like terms on both sides. I'm going to want to solve for the angle. And I notice I also only have sine x. I don't have sine squared. So I don't need to do factoring. What I want to do is I want to try to get sine x by itself. So as far as combining like terms, I could subtract 5 on both sides and subtract the 2 sine x on both sides. That will give me, on the left-hand side, all that I would have left is 2. And on the right-hand side, all I would have left is 2 sine x. So I could divide both sides by 2 and get sine x equals 1. Notice that that's on your pie plate. Sine is your y-coordinate. When is your y-coordinate equal to 1? Right up at the top. So if I was solving for this, questions in degrees, I'm going to make a note here, and we're going to do this often. It's a very good strategy. Before you look back at the question and realize our answer is wrong, is always to solve once around the circle in the positive direction. So there's only one solution when I go around the circle in the positive direction. That would be 90 degrees. But when I look at this question, what domain did they give us? They said, solve it between negative 360 and 0. So they're asking us to solve once around in the negative direction. So our answer is not in the domain. So I'm going to put a little red line through it. What should the answer be? The answer should be negative 270 degrees. But the second part of this question says, then write the general solution. For my general solution, and if you would turn back to 7.1, when we wrote the steps down for our general solution. To find the general solution, the steps are, first solve once around the circle. I think when we wrote out the steps, we were thinking in radians. It said, first solve from 0 to 2 pi. In degrees, it would be first solve from 0 to 360 degrees. And then take all of your answers and add, in this case, 360 degrees times k, where k is an integer. Make all the coterminal ones with that angle. So our general solution, and this is what I would write, we only have one solution between 0 and 360. That's 90 degrees. Add 360 degrees times k, because that would list all the coterminal ones. So on your test, you will have to list all coterminal angles, because that's part of chapter 6. You will have to solve, because that's part of 6. The only thing that won't be on your test is find the general solution, which is combining both of those things together. Now, in your textbook, if you looked at the back of the book, in your textbook in this case, and I'll get your question in a second, I'm going to write or here. The textbook sometimes will write this. And they might have even done that for this answer if you look at the back. This is the same thing. They chose to take the answer that they got from part A and use it instead. But since 90 and negative 270 are coterminal, it actually doesn't matter which one you use as your starting one. You can start with any angle as your starting point, as long as you add 360 and get all the coterminal ones. Me personally, I like to use the ones in the first time around. But it's possible, and if your answer is different than what's in the answer key to the textbook, that would be the reason why. Question? That was your question? Oh, worked out perfectly. Okay, so we're going to find that we're going to do this often in questions. We're going to solve like we would in chapter 6. In this case, I got sine by itself, and then I like to list all my answers in the first time around because they're going to help you. Having all of your answers from 0 to 2 pi is a very helpful thing, no matter what domain they give you. Sometimes, if you try to solve over the domain that they give you first, you're going to make more mistakes. So as an extra step, solving once around the circle first, and then looking at their domain to figure out the answer will be helpful. So let's look at part B. Part B says cos 3x equals -1. It asks us to find the general solution and also to write the answers in the domain from -2 pi to 0. So a little note off to the side. I notice this is a multi-revolution question and a general solution question. So I have to think back, okay? Again, the reason we name these is naming them might help you remember the steps. General solution was solve between 0 and 2 pi, add 2k pi to each of your answers. Multi-revolution question was rewrite the domain, in this case for 3x, then divide by 3, then list your answers. So if I start by thinking that x is between 0 and 2 pi, 3x's would be between 0 and 6 pi, which is 3 times around. I can solve for 3x because -1 is an x-coordinate on my pi plate. When is cos equal to -1? At pi. That's the first time around. Where else is it equal to -1? At second time around, 3 pi. And third time around, 5 pi. Those are the only places where cos is equal to -1. And we went 3 times around. That's a multi-revolution question. Solving for x, then, we would take each of our answers and divide by 3. These are our solutions between 0 and 2 pi. Question, did I make a mistake? Oh, that's a very good question. Yeah. It should be 3. It shouldn't change. And you could leave that as pi, or you could leave it as 3 pi over 3. Thank you for noticing. So, those are our solutions between 0 and 2 pi. We can now write our general solution. Because our general solution says take your answers, solve between 0 and 2 pi. We've done that. Then take each of our answers here's our 3 answers, and add 2k pi to each of them. So if we recap what we did here, we solved between 0 and 2 pi first and had to use our multi-revolution steps to do that. Then we wrote plus 2k pi for each of those answers to make it the general solution. I am going to give you a second method for this same question. Yes?
Do I have to close the bracket in the general solution?
No. You can leave it as a big squiggle and leave it open on the other side. Okay. So this was method 1. We solved first between 0 and 2 pi, used our multi-revolution to do that, and then plus 2k pi all the way through. Here is a second method. If you like method 1 and you want to you don't want to fill your brain with another method, fine. You don't have to, you can choose whichever method you want. This one is a little bit more elegant. So this one, method 2, we do the general solution for 3x first. Then we're going to divide by 3. So what does this look like? We have the same question, cos 3x equals -1. And we ask ourselves, if this was a question that just said cos theta equals -1 and we wanted to write the general solution would look like this. 3x equals. How many times in the first time around can cos equal -1? Only once at pi. Right? Plus 2k pi, where k is an integer. Would you agree? That's the only place that cos is equal to -1 is at pi all the way through. Next, if I wanted to get x by itself, I'd have to divide by 3. And I would get pi over 3 and I'd also have to divide the 2k pi by 3. And this answer here is identical to this answer here. This isn't as elegant as this one. This one's more elegant because you just have one thing listed. So what does this one say and what does the first one say? So we can analyze it. And how did we solve them differently so we can think about it? So if we look at the first one, we solved all the answers between 0 and 2 pi, and we got pi over 3, 3 pi over 3, which is pi, and 5 pi over 3. I'm going to draw a little diagram of that. Here's my unit circle. Can you see that we had pi over 3, pi, and 5 pi over 3, which would cut everything into, like those three things, if you had a circle here, and this was a chocolate pie, every piece would be the same size. 3 big pieces. Okay? So we said, okay, I'll write all the coterminal ones with pi over 3, all the coterminal ones with pi, all the coterminal ones with 5 pi over 3. Because we're jumping all the way around, all the way around. So the first one that's listed, the pi over 3 one, would find all of those ones forever, all the coterminal ones. The second one, pi over 3 plus 2k pi, would find this one and all the points forever with that one. And the third one would find this one and all the points coterminal with that one. Now we're going to look at what happened in the second solution. The second solution says Now, one of your answers is going to be pi over 3. And then you are going to add 2 pi over 3 as many times as you want. So you're going to start here. If you add 2 pi over 3 once, you will get to here. Then you will get to here. And then back to here. Then back to here. Then. And so it gives you the same solutions, but more elegantly because your jumps are smaller. So you have a choice if you have a multi-revolution and a general solution question together. And on the review that I'm going to give you, I'm going to give you both answers. Both with this method and with this method. Questions you can circle are 4, 8, and 9.